Quick question for you. If I told you an instrument signal could range from 0 to 20 milliamps, why on earth would the industry choose not to use that full range? Why start at 4 milliamps instead? Isn't that wasting part of the signal? At first, it sounds like a strange design choice, but it's actually one of the smartest decisions ever made in process instrumentation. Once you understand the reason behind it, you will never look at the transmitter the same way again. So here is the deal. In industrial instrumentation, the universal standard for transmitting an analog signal from a sensor out in the field all the way back to the control room is a 4 to 20 milliamps current loop. Notice, I said current, not voltage, and that difference is important. Industrial plants often have instruments located hundreds of meters away from the control room. Over those long cable runs, current signals remain much more reliable than voltage signals, even in electrically noisy environments. That's one of the main reasons why the 420 milliamp current loop has remained the industry standard for decades. But the real genius isn't just that it uses current, it's where the signal starts. Let's imagine, just for a moment, that the industry had chosen a 0 to 20 milliamp signal instead. Now, picture this. A wire breaks, a connector corrodes, or the transmitter simply loses power. What does the control system receive? 0 milliamps. But here is a problem. Does that 0 mean the process variable is actually 0? Maybe the tank is empty. Maybe the flow has stopped. Or does it mean the instrument has completely failed? Actually, the control system has no way to tell the difference. That's a dangerous blind spot. Now, here is a clever solution. Instead of assigning 0% of the process range to 0 milliamp, the industry assigns it to 4 milliamp. This is known as a live zero. For example, imagine a level transmitter measuring from 0 to 10 meters. When the tank is completely empty, I mean 0 meters, the transmitter doesn't send 0 milliamp. Instead, it sends 4 milliamp. That means if the control system ever receives a true 0 milliamp, it immediately knows something is wrong. It isn't a valid process reading. It could be a broken wire or a power failure. In other words, 4 milliamp represents a real measurement, while 0 milliamps represents a fault. That's the whole purpose of the live zero. It allows the control system to distinguish between a genuine process value and an instrument failure. So to put it simply, 4 milliamp isn't an arbitrary starting point. It's a built-in diagnostic and a safety feature. It's the industry's way to making sure that a loss of signal is never mistaken for a valid measurement. And this standard isn't limited to one type of an instrument. Whether you are measuring pressure, temperature, flow, or level, you will find 4 to 20 milliamps transmitters throughout almost every refinery, power plant, and process facility. Now that you understand why the signal starts at 4 milliamp, the next lesson we will learn how to use it. Thank you.